All right. To start today, we should be on slide number 24 in the note outline. So slide 24 is meant to be a way for us to determine which method to use and then how to set up the integral for each. All right, so let's read slide number 24. It says, write an integral that represents the volume generated when the region bounded by x equals y cubed, x equals 8, and y equals 0 is revolved about, and then you see A, B, C, and D, three different axes of rotation. So first of all, we need to think about what the graph is. Well, I have the graph over here, but if you have x equals y cubed, remember that is also written as y equals the cube root of x. So we have that graph here, but the only part that is real important is the quadrant 1 portion, because x equals 8 is the vertical line over here on the right, and y equals 0 is the x-axis. So we have this region here that is being revolved around different axes. All right, so first of all, y equals 4. All right, so y equals 4, all right, is above the region here. So y equals 4. Now it's not necessarily to scale, but that's okay. That's y equals 4 up there. All right, then y equals -2. Y equals -2 is down here. So we have y equals -2. So we have two horizontal lines that we're going to be going around. Then we have x equals 10. X equals 10 would be a vertical line over here on the right. And then we have x equals -3, a vertical line over here on the left. All right, and so for each one, we're going to revolve around those. All right, so let's start with y equals 4. All right, now, when I look at this, what do I want to use as my rectangle? Well, I could use a dx rectangle, or I could use a dy rectangle. So you really have your options, but let's stick with one of them. All right, so since this equation originally is given in x equals form, I am going to decide to use the dy. So I'm going to draw a dy rectangle. So I draw a dy rectangle. All right, and so that means I need my equation in x equals. All right, so for the first one, since we're going around y equals 4, that means the dy is parallel to y equals 4, and so we are choosing to use the shell method. So we use shells. Part B is also parallel, so we are also using shells. Then part C, now dy is perpendicular to x equals 10 and x equals -3, so we are going to use the washer method. All right, so first of all, we set up the shell method, which is 2 pi times the integral of radius times height with respect to y. Same thing with B, 2 pi times the integral radius times height with respect to y. Washer method, pi times integral of big parentheses with respect to y, little parentheses squared minus little parentheses squared. Then pi times integral of big parentheses with respect to y, little parentheses squared minus little parentheses squared. So we have all of this set up. Now we just have to fill in the specifics. All right, so the first one, y equals 4. All right, so I'm using the shell method. Right? So now remember, the radius is the distance that our axis of rotation is from the rectangle. So remember, we're looking for this distance. Call it r. But what is that distance? Well, keep in mind that the rectangle is y units from the x-axis, which means that the radius is 4 units minus y units. So we have 4 minus y. That's the radius. Then the height. Remember, the height is the length of the dy rectangle. So everybody turn your head to the side, and we see that the upper boundary of the dy rectangle is 8 minus the lower boundary. Remember, the lower boundary is the curve. But what is the curve? Remember, it is not the cube root of x, Rather, it is y cubed, right? We need to be in x equals to use dy. So 8 minus y cubed. So this would be the setup for radius times height, but then we need the limits. All right, we're integrating with respect to y. So lowest y value, which is 0, to highest y value. So what is the highest y value? Well, this point over here is 8 comma 2, right? 8 comma 2, because if y is 2, 2 cubed is 8. So that means we're integrating from 0 to 2. All right, so that's part A. Part B, now y equals negative 2 is below the region. So now what is the radius? Well, the radius now is y, and then there's an additional 2 units here. So I write y minus negative 2, but of course, yes, you could write y plus 2, right? So that would be the radius here. Just like 4 minus y, where we're taking the greater thing minus the lesser thing, because 4 is above the rectangle. Now here the rectangle is above negative 2. All right, height of the dy, once again, turn your head to the side. It is 8 minus y cubed. Notice the height of the rectangle is the same in A and B. All right, limits, once again, integrating with respect to y, still 0 to 2. All right, so now part C. Part C, I've chosen to use a dy, so that tells me I should use washers. All right, so now the washer method. All right, so take a look at x equals 10. 10 is on the right side, so the outer radius, well, is the boundary of the region furthest from the axis, so that is the y cubed, but what's the distance from 10 to y cubed? So we would take the greater thing, the thing on the right, 10, minus the thing on the left, which would be y cubed. So 10 minus y cubed, that quantity squared, minus the inner radius. What's the inner radius? Well, 10 minus 8 squared, right? No need to simplify that. All right, since we're integrating with respect to y, still the integral from 0 to 2. All right, and then the last one. Now we're using the washer method still, but now the axis of rotation is on the left. So now we're thinking the outer radius. Well, the outer radius now, or the boundary furthest from the axis of rotation, is now 8. So now we are taking 8, which is on the right, and subtracting the value of negative 3, which is on the left. So 8 minus negative 3, or of course 11, squared, minus, all right, now the inner radius. The inner radius now is the distance from the curve to negative 3, and so we would write y cubed minus negative 3. Of course, y cubed plus 3 would be fine as well. All right, and we're still integrating with respect to y, so 0 to 2. We could have easily chosen to make this an integral with respect to x, and then that would have meant that A and B would have used the washer method, and C and D would have used the shell method. All right, that is slide number 24. Next, we will be going on to slide number 25.